Hi everyone, this is Mr. Mohammed, and today I'm going to show you how to convert a quadratic function from the standard form to the vertex form, and then we're going to look at a graph on the coordinate plane. The first thing you got to understand is how they look like, right? So I want to convert from this shape, y equal ax squared plus bx plus c, and I want to make it vertex, so y is equal to ax minus h squared plus k. So I need to convert from this shape to this shape. So first identify your parameters. So a is -1, b is 4, c is -1. The problem is, for the purpose of this video and the purpose of completing the square, we don't want a to be any value but 1, so we cannot deal with this. But a good trick we can do is we can actually take -1 as a common factor from the main function. So y is equal to, we take negative outside and change all the signs. It becomes x squared minus 4x plus 1. Alright, that makes a, b, and c different. So I'm going to go ahead and erase them. So now, as you can see, a is 1, b is -4, and c is 1. And that makes the problem go away. So what we need to do next is you need to go ahead and find the value of b over 2 and b over 2 squared. So b over 2 is -4 over 2, which is -2, and when you square it, you get 4, right? Then what you need to do is actually complete the square. So it's going to be y equals to negative x squared minus 4x plus 1, and then I'm going to add and subtract that value I got before. It's going to be +4 minus 4, and when you add +4 and -4 to the equation, you actually didn't do any changes, just like adding or subtracting a 0, right? But what that does, actually, if you think about it, you are going to have a complete square out of these numbers. You see that? Yeah, you're going to get a complete square. That y becomes negative. Inside it's going to be x minus 2 squared. Okay, so that's the three terms. X squared minus 4x plus 4 is x minus 2 squared, and you can try doing this on your own. And at the end, you're going to add the remaining terms, which are 1 minus 4, and that gives you -3. It's going to be -3. Okay, so let's go back here. Okay, wonderful. So just a little simplification to this function. So y is equal to negative times positive negative, x minus 2 squared, and negative times negative is positive 3. And that's exactly how the vertex form of a quadratic function should look like. It's a is -1, h is 2, k is +3. And the good way to check if your answer is correct is by looking at a should have the same value of a in the previous one. So a here is -1, and previously a was 1, but of course we multiplied by negative, so a actually was -1, as you can see right up there. A was -1. So moving forward with this, we need to graph this function. So the function looks like this. It's negative x minus 2 squared plus 3. So that means its vertex is 2 and 3, and the parabola is looking downwards because a is negative. So by using a small table of values, x and y, put the vertex in the middle, 2 and 3, and choose any other value before 2 and after 2. So before 2 I have 2, 1 and 0. I have after that 3 and 4, and substitute in the main function to get the value of y, and that gives you a better graph. So putting x equals 0, so if x here is equal to 0, 0 minus 2 is -2, square it becomes 4, 4 times negative 1 is negative 4 plus 3 is negative 1. Put x is 1, 1 minus 2 is negative 1, squared becomes 1, multiplied by negative 1 is negative 1, plus 3 gives you a 2. And normally these numbers reappear again in perspective. So let's plot these points. I have the vertex at the most important point, which is 2 and 3, and because this parabola is looking downwards, this point right here is a maximum point. So 2 and 3, 1, 2, and 3, so the point is right here. That's the vertex, so I can call it V. And then you have 0 and negative 1, that's your y-intercept, 1 and 2, and 3 and negative 2, 3 and 2, sorry. And last point is 4 and negative 1. So it has to look something similar to this. Then, smoothly, you're going to graph the parabola, like so, looking downwards and everything. And you can also check if the y-intercept is the same in this function. Y-intercept is negative 1, and as you saw before, c also was negative 1, so that's the same value. So also you can check with the vertex. The vertex right here is at 2 and 3, and that's our vertex right there. And that's how we do this.